Hello everyone, welcome to the course of Gate Crash course actually from Geeks for Geeks. In this particular session, we will discuss about the one of the most important topic in compiler design, that is lexical analyzer or scanner. So we will cover this topic in this session for next 2 hours. We will actually finish this complete topic, and I will be assuming that you don't know anything about this topic. There is no prerequisite, okay? And this topic is one of the most important topics in compiler actually. So we will cover this topic. So before moving on, before covering this topic in detail, please let me know if I'm audible to you people or not, properly audible, and the screen is visible or not. Please write in chat if I'm audible or not. Everyone, please write in chat. If I'm audible and visible properly, please write in chat, confirm me so that I can continue. Anyone? So meanwhile, I get the response from you people. So let me tell you, okay, how this Gate Crash course launched by the Geeks for Geeks is helpful for you people. How this can help you in your Gate preparation. Okay, so actually this Gate Crash course is designed for specifically for two type of students. One is those students actually who are not prepared yet, who are not serious about the exam, or maybe they don't get time. They want to crack the gate exam but they don't get time, and they're not sure that okay they will clear the exam or not, they will clear the exam or not, I'm using this word. Okay, so this Gate Crash course is actually will make sure to the students that okay those are not sure that okay they will be able to clear the gate exam or not. This Gate Crash course, complete Gate Crash course, will ensure you that your at least your gate exam will be cleared. After taking this course, your gate exam at least will be clear. I'm not talking about 60 marks, 50 marks, I'm not talking about that, but at least your gate exam will be clear. If you are not assured that okay you will be able to clear the gate exam or not, just you are interested to appear for the gate exam and you want to clear it, so this Gate Crash course is for you. Okay, and the second type of student for whom also this Gate Crash course can be helpful is the those student actually who have prepared a lot. They want to revise now, and I have to say that they want to revise the most important topics, or I another word I can use, most expected topics for Gate 2023. Okay, so in this course actually we are covering most expected topics which are going to become in Gate 2023 from every subject. You can see that this is my first lecture from compiler design. After this first lecture, 4 more lectures will go and in every lecture there will be one important topic from compiler design. Similarly, from every subject this is going on, we are taking only 5 topics, 5 most important topics, 5 most expected topics which can come in Gate 2023. Okay, so only we are covering, we are not covering the complete syllabus here because we don't have time also, and that will not be useful at this time for you people. What will be useful if you are serious about Gate exam and you want to revise, it's better you revise the most important topics. So here we will cover these most important topics from every subject. 5 most important topics from every subject we will cover. In every lecture there will be one topic, and that will be helpful for you because this topic, let's suppose I'm covering lexical analyzer. After this lecture I can ensure you that you can attempt each and every question from this topic. After attempting the Gate exam, you can again come back to this video and you can write in the comment that sir I was not able to attempt the question. If you have taken this lecture seriously, believe me, you will be able to attempt all the questions related to this topic because we are not going to leave anything. See, what we are doing here is, in this lecture, we are not doing any magic. We are simply covering each and every concept related to lexical analyzer. After that, after covering the concepts, we will cover all the last 30-year gate questions. We will attempt all the last gate 30-year questions, and me alone will not attempt all these questions. You people will also attempt. You people will also attempt with me. Okay, so believe me, I will just tell you the concepts. I will tell you the concepts of lexical analyzer, and then we have, I can show you right now also. I can show you. So there are some easy way to explain the things also. I'm using that thing. So okay, I will show you. I will show you the, we will cover various previous year gate questions, and first I will ask you people. You people try yourself, and people will be able to solve these questions. After, I will cover the fundamentals and some examples related to this topic. Okay, this is what we are doing with every topic, every five most important topic in every subject. Okay, so let me wind up this thing now, and let me come back to my this today's topic. So the benefit for this complete gate crash course, this will go for 1.5 months maximum. We are covering five most important topics from every subject, and if you are beginner, that is going to help you, because this course, I'm telling you, will ensure you to clear the gate exam. Why I'm saying this? Again, there is no magic. We are covering five most important topics from every subject. Every year the question is coming from there. Every year, maybe this year don't come. So another topic from, we have five chances with us. We have five chances with us. Okay, even one chance will be get hit. Five most important topic we are taking, and even one chance get be hit. One topic will come. You people will be able to attempt to 11 to 12 questions. 11 to 12 question means you will be able to attempt near about 30 marks paper. Okay, near about 30 marks paper you will be able to attempt. Okay, so this will ensure you, definitely this is going to ensure you that this crash course is going to ensure you that you will clear the gate exam. Okay, and you are, if you are serious, already serious about the gate exam, you have already done so much, then this is a revision for you people for the most important topics. Okay, so that's it from my side. So keep with me, and let's start with this one of the most important topic in in compiler design, that is lexical analyzer. Before moving to this topic itself, let me tell you. Okay, one of the student asked me actually in one of the gate class, sir, can I leave this subject, compiler design? This is only of maximum of 4 marks. This is of 4 marks paper subject actually. 4 marks, or sometimes 6 marks paper come from compiler design, sometimes only. So maximum time 4 marks paper come from compiler design. So what I can tell you people is that, see, no doubt these are 4 marks. Okay, maybe you can, first of all, you should not think that this is small number. Okay, because this can make the difference of 1,000 ranks. This can, 1 marks even can make the difference of 100 of ranks. Okay, so these are 4 marks. First of all, maybe you get the easy question from here only. Okay, another thing I'm telling you, see, I'm covering only 5 topics. We are covering only 5 topics from compiler design. I'm not covering complete compiler design now. I'm covering only 5 most important topics. So at least for 4 marks, we can study 5 lectures. We can cover 5 lectures in which we are completely finishing those topics. So I'm not asking you to cover the complete compiler design. I'm just asking you to cover these 5 lectures of compiler design for these 4 marks. Okay, so that is not a bad trade actually. And if you have any doubt related to general doubts also, you can ask me right now. And after that, I will start with my topic, today's topic, lexical analyzer. We will finish this topic. Even you don't know anything, I'm not bothered about that. I will tell you right now. I will give you the information right now, and you people will be able to solve the question right now. Which question? The gate previous year questions. These questions are not my question. Okay, these are gate standard level questions which already come in previous exams, and you people will be able to solve those questions. Okay, so meanwhile, moving to this topic, if you have any general doubt related to this crash course or how that can benefit you or anything, you can ask me. Okay, then After 10 seconds, I will move on that. Sainath is asking, okay, can I watch if I'm starting this course now? See, this course is designed, this is a very beautiful question actually. This will help lots of students also. Every lecture of this complete course, I'm telling you, every lecture of this complete course is designed in such a way that even you are attending one lecture only, you can attend that lecture without knowing anything back. You can attend that lecture without knowing anything about that subject. Okay, every lecture is designed in such a way in this series actually. So if you will find out the thumbnail, please check out the thumbnail of every lecture. We have written complete. We have written over there complete. Complete means we don't expect you need any prerequisite for that. Every lecture I'm talking about. When second lecture will come of compiler design, I will not ask you about the lexical analyzer. I will not ask you about the lexical analyzer. Okay, so even though I'm starting today lexical analyzer, I'm not asking about the basic automata also. Some people say that automata is the prerequisite of the compiler. Okay, I'm saying whatever will be required, I will tell you right now. Not too much information is required, little bit is required. I will tell you right now, I will finish it. And you do not need any prerequisite for any lecture. I'm telling for any lecture in this course, not only about mine, for any lecture. Okay, you can attend any lecture, you can take that topic and you can finish that topic. Okay, and you can enroll in this course. This is free course. So if we are getting the free knowledge, and so you can register in the course. The link is already available, so you can register over there if you have not registered. Every lecture is just like individual lecture, and that topic will be finished for get point of view. Okay, so let's start with today's class. So we are going to cover the lexical analyzer, which is also known as the scanner. नाम से ही पता लग रहा है अपने को, scanner, that is going to scan the strings, that is going to scan your program actually. Okay, so lexical analyzer is the actually first phase of the compiler. That is the first phase of compiler. We have 6 phases in the compiler, and this is the first phase of compiler. In 5 lectures we are going to cover the most important phases of the compiler actually. Okay, so this is the first phase of the compiler, and we will finish it today only. Okay, lexical analyzer actually, in lexical analyzer, we take the high level language as an input. We know that what compiler do, take the high level language as an input, convert into low level language. For example, if we are giving C, if you are writing code in C language, that will be converted into the assembly language if you are talking about the C compiler. Okay, every compiler is doing like that, converting high level language into low level language. Okay, so this is the first phase, which is taking the high level language and which is scanning the high level language, and actually finding some information for the compiler. What information? We will discuss that, like tokens that is finding. Like I will say, okay, in simple language, that is finding, okay, which are the variables, which are the operators. Okay, if I write, okay, A plus B, I write, okay, C equal to A plus B. Now this is high level language. I give it to the lexical analyzer. So the lexical analyzer will tell us, okay, I'm using plus operator, I'm using equal to operator. These are the operators I'm using. This is telling me, okay, these are the operators you are using, and these are the variables, or we can use another word, identifiers. These are the identifiers. C, A, B are the identifiers. So simply this is telling us, this is dividing a big statement into small parts actually. Okay, small groups actually. So this is one group, this is another group. Okay, so meanwhile, right now I'm just telling you, this is the first phase of the compiler. Okay, we will cover from very basic, from the definition itself. So I have some so we will cover what is lexical analyzer, functions of the lexical analyzer. We will cover various examples. These examples are designed in such a way that you can solve maximum gate questions, maximum PYQs you can solve. That these examples is covering all the concepts actually. Okay, so let's start from very basic. Which is the first questions comes in our mind, what is lexical analyzer? So lexical analyzer is one thing, is that is the first phase of the compiler. And what is the main role of that phase? The main role of lexical analyzer is to identify the tokens. And what is this tokens? So that is identifying the tokens. What is this token? Okay, let's try to understand it now. So let's suppose he is saying I'm high level language. This is our high level language. This is one statement written in high level language, and position equal to initial plus rate into 60. Okay, I have just taken the standard from the book actually. From Ullman book actually I have taken this example, but just I try to animate it. So this is high level language, and we provide the high level language to the lexical analyzer, who is the first phase of the compiler. And this first phase of the compiler is asking to the high level language, who are you? He is asking him, who are you? Who are you? So this lexical analyzer is asking to the high level language, who are you? Okay, then he is telling that, okay, out of these things, these are telling that, okay, position, initial and rate, this position, initial and rate is telling that we are tokens. We are tokens. We are one type of token. Which type of token? Identifier. We are identifier and we are tokens. Tokens are one smallest unit. You can say, okay, one of the smallest unit inside this statement. Okay, so position, initial and rate are some similar type. These are variables. Actually, we also call them the identifiers. We call them identifier, and these are tokens. Actually, these are tokens. So they are saying that we are tokens. Similarly, other tokens also come, plus and multiply also come. They said we are also token. We are also token, but we are operator type of token. We are operator. These are operators. Okay, equal to is also there. I do not mention here. Let me mention here. So equal to, plus, multiply or equal to. These are operators type of token. Okay, these are different type of token. These are different type of token, but these are also tokens. These are also tokens. Okay, another type of tokens which lexical analyzer find out is the constant. 60 says I am also a token, but I am a constant token. Okay, so you can here see that what lexical analyzer is doing is that is taking a high level language, high level statement, dividing it into some groups, group 1, group 2, group 3. This is one type of token in group 1, which are known as identifier. Another type of tokens is the operator, plus, multiply, equal to. Another type of token is the 60, which is a constant type of token. So what this, if somebody asks you what is lexical analyzer, it is the first phase of the compiler. He is the first phase of the compiler, which is taking high level language as an input and providing us groups, some group of tokens. Okay, like identifier, operators and constant. ये इन तीनों को अलग भी कर रहा है, इन तीनों को क्या कर रहा है, वो अलग अलग भी कर दे रहा है. ओके, ये एक ग्रुप है, ये दूसरा ग्रुप है, ये तीसरा ग्रुप है. इस ग्रुप के अंदर आइडेंटिफाइड टाइप के टोकन्स आ गए हमारे, इस ग्रुप के अंदर ऑपरेटर टाइप के आ गए, इस ग्रुप के अंदर हमारे कांस्टेंट टाइप के आ गए. तो दो काम ये कर रहा है. ये जो लेक्सिकल एनालाइजर है ना, ये दो काम कर रहा है. एक तो ये टोकन्स को फाइंड आउट ही कर रहा है, सभी टोकन्स को फाइंड आउट कर रहा है. हाँ, कर रहा है, बिल्कुल कर रहा है. दूसरा काम क्या कर रहा है, यहाँ पर ये इनको ग्रुपिंग भी कर रहा है, इनकी इन टोकन्स की ग्रुपिंग भी कर रहा है. एक टाइप के टोकन्स ये हैं, दूसरे टाइप के टोकन्स ये हैं, तीसरे टाइप के टोकन्स ये हैं, इस हाई लेवल लैंग्वेज के अंदर. Okay, so that's it. This is the main job. I say main job. I say main job. This is the main job of the lexical analyzer. There are many other also. We will cover that also. But this is the main job, to find out the tokens. To find out the tokens. So what are tokens? These are smallest unit, I can say. These are the small one. How you can divide it? This statement. This is one thing. Equal to is another thing. Initial is another thing. Plus is another thing. So these are the smallest unit, we can say, inside the high level languages, which are identified by the lexical analyzer, and we simply give them a name. And what is that name? That name is token. That name is token. And that group also, similar type of tokens, that is grouped also by the lexical analyzer. That's it. This is lexical analyzer. This is lexical analyzer. If any doubt, please ask me. Please write in the chat if you have any doubt. We will finish this topic starting from very basics, and we will cover all the previous year gate questions, and you people will solve yourself, because nothing will be left. We will cover everything. Then they cannot generate the question out of the concept. They cannot generate the question out of the concept. They need to generate from those concepts only. So I don't think if the question will come from this topic, I'm making you sure that you will be able to crack that. You will find that question very easy. Believe me. Please, but ask the question. If you have any doubt, please write in the chat. That you need to do. Please write in the chat if you have any doubt. Please. Okay. So I'm moving on. If you have any doubt, you can write in the chat. So still I'm moving on. Okay. So let's see the working. How that is finding the tokens. One thing is clear. Lexical analyzer is finding the tokens. That is the main role of lexical analyzer. But how that is finding the tokens? Okay. Let's identify that thing. Okay. Thanks for replying. Okay, clear है. Okay, so कैसे काम कैसे कर रहा है अब ये काम कैसे कर रहा है, टोकन्स को फाइंड आउट कैसे कर रहा है. देखो कैसे कर रहा है, ये क्या करता है. ये हमारे पास हाई लेवल लैंग्वेज है. दिस इज आवर हाई लेवल लैंग्वेज. ओके, एक स्टेटमेंट हमने उठा ली. We feed it to the first phase of the compiler, lexical analyzer. Okay, this lexical analyzer, what that will do is now that will identify all these different type of tokens here. Maybe these are identifier type of token, these are operators type of token, plus equal to and star, this is constant type of token. So one token he find out is the position. Okay, so he is saying that this is an identifier. This is giving us two information. After looking at this, lexical analyzer will start from the very first character actually, and that will keep moving on. Okay, so from very first character that will start, and that will identify that okay, this is a variable, this is an identifier. So he will mention that thing, this is an identifier, and after mentioning that thing, lexical analyzer will store this identifier into the symbol table. So what is symbol table? Symbol table is a data structure used by the compiler. Compiler use this data structure to store what? To store identifiers, to store the identifiers. So you have maybe you have using the variables. Identifier nothing, variables you are using in your program. So these variables are stored where? In the symbol table, in this data structure. This data structure is used by the compiler. तो ये क्या कर रहा है लेक्सिकल एनालाइजर आपका? कुछ नहीं, यहाँ पे ये इसने उठाया, इस वेरिएबल को उठाया, इस आइडेंटिफायर को उठाया, सिंबल टेबल में डाल दिया. किस पोजीशन पे डाला? इसने बोला इसको ये टोकन नंबर 1 है, ये टोकन नंबर नंबरिंग कर दी उस टोकन की, सो दैट कैन आइडेंटिफाई लेटर ऑन. ओके, सो इसने बोला ये टोकन नंबर 1 है, आई असाइन इट, आई फर्स्ट टाइम आई फाइंड आउट दिस टोकन एंड आई स्टोर इट in the table, and its number is 1 now. Okay, so that later if you will use this variable in the program, then the compiler can find out this variable here in this symbol table. Okay, और ये किस टाइप का है? ये फ्लोट टाइप का, उसने बता दिया ये किस टाइप का है, फ्लोट टाइप का है. Okay, so maybe we have assigned it earlier on. Okay, उसके बाद ये अपने को आइडेंटिफायर मिल गया. उसके बाद अपने को क्या मिला? इक्वल टू. उसके बाद अपने को क्या मिला? इक्वल टू. मैं ऊपर से रब कर देता हूं यहां से. अपने को क्या मिला? उसके बाद इक्वल टू मिला. इक्वल टू क्या है? एक ऑपरेटर है. ओके, क्या है? इक्वल टू ऑपरेटर मिला अपने को. ऑपरेटर्स जो है ना वो सिंबल टेबल में स्टोर नहीं होते हैं. देखो ये इंफॉर्मेशन, इसके ऊपर भी क्वेश्चन है, कि भाई ये जो आइडेंटिफायर्स होते हैं ना वही सिंबल टेबल में स्टोर हो रहे हैं. जो ऑपरेटर्स मिलेंगे ना लेक्सिकल एनालाइजर को, ये सिंबल टेबल में स्टोर नहीं हो रहे हैं. क्यों नहीं हो रहे हैं ये सिंबल टेबल में स्टोर? क्योंकि ये तो कंपाइलर को पहले से ही पता है. जब आपने कंपाइलर डिजाइन किया था, जिसने भी कंपाइलर डिजाइन किया था, उसने सभी ऑपरेटर्स को ऑलरेडी डिफाइन करके रखा हुआ है. उसने जो कंपाइलर इज ऑल्सो अ प्रोग्राम, उस प्रोग्राम के अंदर उसने सभी के सभी ऑपरेटर्स को ऑलरेडी डिफाइन किया हुआ है. आइडेंटिफायर्स को किया है क्या? वेरिएबल्स को नहीं किया है. उनकी इंफॉर्मेशन तो चाहिएगी. उनकी इंफॉर्मेशन के लिए डेटा स्ट्रक्चर हम यूज कर रहे हैं सिंपल टेबल, और उसमें स्टोर करते जा रहे हैं. कौन कर रहा है स्टोर? मैं नहीं कर रहा हूं, ये लेक्सिकल एनालाइजर कर रहा है. अगर आपसे पूछे ना ये सिंबल ये कौन स्टोर कर रहा है, सबसे पहले कौन स्टोर करता है इसके सिंबल टेबल के अंदर? तो कौन स्टोर करता है? लेक्सिकल एनालाइजर स्टोर करता है. पर इसमें एक क्वेश्चन और है एग्जाम में आपके, क्या खाली लेक्सिकल एनालाइजर एक्सेस करता है क्या सिंबल टेबल को? नहीं, सभी के सभी फेसेस एक्सेस कर सकते हैं, सभी के सभी फेसेस इस सिंबल टेबल को एक्सेस कर सकते हैं. दे कैन मॉडिफाई दिस, दे कैन समहाउ मॉडिफाई इट. ओके, तो ये सिंबल टेबल को सभी के सभी फेसेस एक्सेस कर सकते हैं, क्योंकि सभी को यूज करना पड़ेगा इन वेरिएबल्स को. जो जो वेरिएबल्स आपके आएंगे सबको आगे जितने भी आपके 6 के 6 फेसेस हैं वो इसको यूज करने वाले हैं, इस डेटा स्ट्रक्चर को. खाली ये फेज नहीं करेगा. ओके, ये ठीक है, ये हमारे टोकन फाइंड आउट कर रहा है, इसको करने देते हैं. इसने नेक्स्ट टोकन फाइंड आउट किया इनिशियल, दैट इज अ वेरिएबल. अगेन ही इज सेइंग दैट इज आइडेंटिफायर एंड आई हैव गिवन अ नंबर टू इट 2. आई स्टोर इट इनटू द सिंबल टेबल. अब ये इसने लिखा है, लेक्सिकल एनालाइजर ने ही डाला है इसको, ये पहले से नहीं था यहाँ पे. इसने लेक्सिकल एनालाइजर ने इसको स्टोर किया, इसको एक टोकन नंबर असाइन किया और इसका टाइप असाइन किया. व्हाट टाइप ऑफ variable is this? Float type. Okay, so that must be mentioned earlier. Actually this is float, position is float, this is also float, this is also float. Actually I think rate is also float, so this must be mentioned. Then only that will mention that okay, this is float type. If this is type int, then that will type int here. Okay, all this is done with the by the lexical analyzer. Okay, okay, let me speak in English now. If you are asking me to deliver in English, it's okay. So next one is the plus. Plus is another operator. That is an operator, that is a binary operator, binary addition. Two numbers are required for addition, like 5 plus 6. Two operands are required. Okay, I cannot write 5 plus this don't have any meaning. Okay, I need to provide two operands, so that's why this is binary operator actually. Okay, this is operator and binary operator. We do not need to store it into the symbol table. Very easy. Next one is the identifier. We store into the symbol table, give it a token number, that's it. Next one is the multiply. That is an operator, binary multiplier. Matlab means we need two operands to multiply. I cannot say like this doesn't have any meaning. This need two operand, so that's why this is binary operator, binary multiplier. Another one is 60 is a constant, which is an integer constant they have mentioned, because this is not like this. If this is dot 0, dot 5, dot 1, then this could mention that this is a float. Okay, so this identifier, lexical analyzer is identifying, that is scanning the string from left to right like this, scanning this. All the symbols are scanned here, and some of the identifiers are stored into the symbol table and others are also identified. Okay, so all these symbols are identified and this stream is created. This stream is given a special name that is known as token stream. This stream is given a special name that is known as token stream. For example, nothing, just position is what? Position is what? Position is an identifier which is having token number 1 into symbol table. See this one, token number 1, and this is an identifier actually. ID is showing that this is an identifier. After that we find equal to, after that we find initial is an identifier which is in symbol table at second position, or which is having token number 2 here. That's it. So after that we get plus is here. After that we get rate is here. Identifier with 3 token number in the symbol table. After that we get multiply 60. So this all become, actually this stream will be passed on to the next phase of the compiler, that is syntax analyzer phase. To syntax analyzer phase, this token stream will be passed. So if somebody asks you what is the input of the lexical analyzer, input of this phase is the character sequence. You can say that character sequence. So and lexical analyzer scan the characters, scan the string, this string actually character by character. Okay, just like character by character means actually that will start from P, then O, then S. In position also P, O, S, I, T, I, O, N. After that gets space, so that can identify it. Okay, this is a variable. Okay, so this is scanned from left to right. This stream, this complete string, character by character. And what is the output? Somebody asks you what is the output of lexical analyzer? Token stream. And these identifiers are stored into the symbol table by the lexical analyzer. So we get so many information from here. Anything else, please ask me, ask any question which is coming in your mind. The important thing is that there should not be any doubt in your mind. If any doubt is there in mind, then there may be a problem, there may be a chance that you are not able to solve the question in exam. But if there is no doubt, I'm giving you surety, you will be able to attempt every question, and you can check it right now in this lecture when we will attempt previous year questions. Okay, so please write if you have any doubt. Clear that doubt, then we will move on. Simple. That is taking this stream of this is a string, complete string as an input, scanning it character by character, identifying the tokens, and after that, that is generating a token stream. This token stream is given pass on to the second phase of the compiler. This is the first phase, lexical analyzer. Second phase of the compiler is actually syntax analyzer. Okay, okay. So that's it about it. Now, again, from very basics, definition of lexical analyzer. Now you can understand the definition also. So lexical analyzer is the first phase of the compiler. Yes, you people already know this thing. Which will divide, you already know this thing, which will divide the source code, high level language, into smaller, similar type of groups, which divide the source code, high level language statements into similar type of groups, like operators, like identifiers, like constant. These are different groups of tokens. Okay, simple. That is given in the definition what the lexical analyzer is, and these groups are known as the tokens. So you people know what is the definition, what this definition is talking about. Even we can understand with this diagram in more clearly. Same thing I'm repeating again and again. We have a statement, if this statement, let me write it right here, if x is greater than 3.1, this is the statement, high level language. If this is the opening bracket, x is greater than 3.5, let me write the closing bracket also. Okay, okay. So this is the high level language we have. We give it to the lexical analyzer, and that what that is doing, finding out the tokens, like if is a keyword, these are the brackets. X is an identifier, we use one identifier x only here. Greater than is an operator, 3.1 is a number, 3.1 is a number, or you can say that constant number. Okay, so these are the same thing given in the definition also. Okay, one more thing I'm adding here in this slide. Actually, I have one more thing, and yes, you're asking that, okay, sir, only identifiers are stored in symbol table. Yes, only identifiers are stored in symbol table. Okay, only identifier. See, you people tell me, okay, compiler know about the operators or not? Compiler already know about all the operators. Compiler are, when somebody was designing the compiler, that will define, okay, this means is greater, this mean is smaller, this means smaller, this operator means is equal to, this is multiply. So if we will not define the meaning, how we will use them if a compiler don't know these operators? Okay, and another thing, keywords also. Keywords, compiler already know about if statement, for statement, while statement. These are keywords already defined in the compiler. If they are already defined, why we are unnecessarily storing them in symbol table, in our data structure symbol table? We will store only those things in the symbol table which are new, and identifiers are the new one. Identifiers are the new things which you are entering into the, which are giving as an input. Okay, okay, I will come to your question. Next question is from Sainath. Is this crash course is sufficient to solve questions of gate? I will solve here 10 to 15 questions from gate, from lexical analyzer. I will solve here itself, and you people will also be able to solve. You will solve yourself. I will not solve, you people will solve yourself. I will just giving you this information. If you know this information, you can solve. That's it. Okay. Okay, so this is about the lexical analyzer. One more thing I want to add here is that, let me erase this screen first, and this is also important. Lexical analyzer is developed actually using finite state automata. If we know about little bit about automata, so we have states and we make the transition from one state to another state. Okay, so we know finite state automata. So we are using this machine, this finite automata machine actually is working behind the scene, behind the lexical analyzer. This machine is actually scanning the characters one by one. That is scanning the characters one by one. So maybe it's like that. Okay, first I find I, then I find F, and after that I find space. Then I can say that okay, this is a keyword. This is a keyword. So this should be the final state. Final state. Okay. Similarly, let's suppose this is our start state. I start from here. First I find I, then I find F, and then I find space. Then I say that okay, this is my final state, and I can say that this is a keyword. This is a keyword. Similarly, I can go for others also. I find F first, then I find O, then I find R, and after that I find space. After that I find out space. That means this is again a keyword. 4 is again a keyword. But after this, if I find out something else like K, fork, now this is not a keyword. This become a variable. Maybe after that, if I find out opening bracket and closing bracket, opening bracket and closing bracket, now this become a function. What is the name of function? Fork. Okay, so these all are developed with the help of this machine actually. All the keywords, everything is developed with the help of a big finite automata machine. This machine is working behind the scene, which is finding out this is keyword, this is a opening bracket, this is identifier, this is a operator, this is a constant. These all are identified with the help of finite automata, finite state automata. Okay, this machine is working behind the scene. This is the only thing you need to know. How this machine is working, you do not need to go inside that. I just give you an idea how this machine is working on. Otherwise, you do not need to develop this machine yourself. They are not going to ask you how this machine is developed actually. So you need to just know that okay, a little bit you need to know the idea. Okay, if we are starting, let's suppose if we are finding if keyword, then there must be space after if. There must be space after for. If there is no space, then that become a variable. Again, if you find out bracket, that become a function. Okay, so for being a variable, for being a keyword, you need a space. If I add something else, then that become a variable. But if I add something, I do not give any space here, I add brackets, this become a function. This become a function because we know that every functions have these brackets. Okay. Okay, so only one thing I tell you actually is that one thing I tell you only in this is that finite automata machine is actually working behind the scene, behind the lexical analyzer. Okay, which is finding out the tokens. Okay, so this was the introduction to lexical analyzer. Now that is finished. Okay, I will take 2 or more, maximum 3 slides. After that, we will solve the questions only. Okay, so I'm using a word. I'm already saying you that okay, the main function of lexical analyzer is finding the tokens. Main function. I'm saying main function. So there are many other functions also. There are many other functions of the lexical analyzer. Lexical analyzer phase, first phase of the compiler, have many other functions. Which are those functions? Oh, okay, this we already know. Divide the program into tokens. This is the one function of, we already know. We have already discussed so much because this is the most important one also. Another functions of this phase, lexical analyzer phase, is remove the comment lines. You must be using the comment lines in your program. Maybe like this, maybe like this in C++. So if you are writing something after this comment line is removed at first phase of the compiler. They see what they can do is they will ask question from here only. They cannot ask question from out of the concepts, but they can change their question. What they can ask is, which phase of the compiler remove the comment? You mentioned the comments in your program. Who remove the comments? Which phase of the compiler remove the comments? First phase of the compiler remove the comments. Who remove the comments? First phase of the compiler remove every type of comment from your program. Okay. Another function of lexical analyzer is removing white spaces. See, white spaces are allowed in C language, in C++ also, in Java also. White spaces are allowed. Even if I will write that, okay, I equal to, after taking 10 space, I am writing 5. This will work. So this is unnecessary space I am giving. Even though you are giving one space only, this will also work. And if I'm not giving space, this statement will also work. This is also working. I'm not giving any space between I equal to and 5. Here I'm giving one space. Here I'm giving lots of space. All will work. So this extra space is removed. This white space is removed by which phase? Lexical analyzer phase. Okay. Okay. I'm coming to the comment section. This is your chat box. But let me finish this slide. Another one is give error message by providing line number and column number of the code. When you compile your code, you get the error. And you also get, okay, in which line the error is occurring, in which line. Line number 50, the error is occurring. So who is telling line number, in which line error is occurring? This phrase is helping. Telling us about the line number and column number, in which particular line the error is occurring. This information is tell us about by the lexical analyzer. Okay, so these are the functions of the lexical analyzer. Yes, these are the functions of lexical analyzer. So let me go to the, you can ask any question till now. Any doubt, please clear your doubt. So you're asking that Jerry is asking that, okay, if there is no space, if somebody define it like this, okay, see, if somebody is defining this, this again have different meaning. This is a function, this is again a function, but this is a inbuilt function. Okay, this is a keyword. This function is built with the help of a keyword, you can say that. Okay, so actually we use this as a loop only, but this function is helping us to execute the loop. This function is helping us to execute the loop. Okay, so that doesn't mean that, okay, this is a keyword. What I was trying to tell you that lexical analyzer scan character by character. That read F first, then he find out O, then he find out R. Okay, after that, okay, we know this thing. This thing is already known by the compiler. Okay, he also know this thing. He also know this thing. But if I say that FOR, let's suppose I write, I don't know, I can write any word. Let's K. If I write K here, and there is a space here, there is a space after this, then this will be considered as an identifier. And this will be considered as an keyword. And if I'm writing FORK brackets also, there is no space after this, this is considered as a function. We know this thing, this is a function, this is a variable if there is a space out of this. So how the lexical analyzer is identifying? His DFA, his finite automata is finding out, okay, if there is a space, then this will be considered as identifier, otherwise this is considered as a keyword, otherwise this will be considered as a function. Okay, so this is what I'm trying to tell you that. Okay, how that is differentiating between keyword, variable, and the function. So this space is actually helping. There is a question also in GATE exam related to this itself. More clarity will come from there. Okay, if any doubt still, you can ask, please. Anyone, any doubt, please ask. Otherwise, now we are taking some examples. We are third part of our session. Here we are going to take the examples. After these examples, we will cover the gate questions. Okay, so just give me a minute. You try to solve this question and write the answer in the text chat box. Please try it. Anybody can give me the answer. Okay, we get Kavya says 10, Sri Harsha says 10. You people are right actually. So don't worry, I'm going to give you some more tough questions also. I will not leave you. If you already prepared, then also we have some other tough questions for you people also. Okay. So meanwhile, you people please keep helping. If you please keep replying so that other people can also get help. So here, this is the program. We need to find out number of tokens in this C language code actually. Number of tokens. So we are already getting 10. 10 is the right answer actually. How they are finding 10 is see how they are finding 10. This is one token. This opening bracket is another token. This closing bracket is another token. This curly brace is opening curly brace is another token. This int is another token. I is another token. Comma is another token. J is another token. 6, 7, 8. This semicolon is another token, and this is the last one. So total number of tokens are 10 here. Total number of tokens are 10 here. So any doubt in this, please ask. One doubt may be there. One doubt, let me generate the doubt from my side. So one doubt may be there. Token, okay, answer is 10, right? One doubt may be there. Some people, if they are trying first time, they think that, okay, this is one token. This is one token. See, this will be considered as two tokens, two different tokens. This is main will be considered as different tokens. This opening bracket will considered as different token. This closing bracket will be considered as different token. Okay. So if you are defining a function, this is how the tokens will be counted. Okay. So why this is counting like this? Why this is not considering like this? See, this is not my fault. This is how the compiler is designed. This is how compiler is designed, how they are counting the tokens. Okay, if I have generated the compiler, I may make it as a one token, but they consider it as one token, and opening bracket as another token, and closing bracket as another token. Okay, so these are three different tokens. This is not one token. This is what we are telling. This is the key which you can take from this program actually. Lexical analyzer consider main as one token rather than this. Okay, that consider function name as a one token rather than this complete. Although this complete have some meaning, this is a function we know, but still that is considering this is a one token, this is another token, this is another token. So there are some important points we will cover one by one. रिकर्सिव फंक्शन कॉल में कैसे करें? रिकर्सिव फंक्शन कॉल में कैसे करें tokens count? Can anybody tell me? This is recursive call. Okay, please tell me how many tokens are here. You people please tell me. Please write in the chat box how many tokens are here. This is a recursive call. How many tokens are here? Lexical analyzer is not worried. You can note down. Lexical analyzer is not worried about what the hell you are doing in the program, whether your program is working fine or not. Lexical analyzer is not bothered about the meaning of the program. Lexical analyzer is not bothered about the meaning of the program. If I write, say that A, B, C, D, E, F, G, H, unnecessarily I am writing this thing. Lexical analyzer, first phase of the compiler, pass this code on. This will send this code to the second phase of the compiler. That is not bothered about the syntax. Who is bothered about the syntax? Second phase of the compiler, syntax analyzer. Okay, so lexical analyzer is not bothered about. So don't bother about how this program will work. Just simply tell me how many tokens are here. So Sainath saying 9 and Jerry is saying 18. 18. Okay, so let's see. 1, 2. No, one thing is clear. After this lecture, everything will be clear. One thing, this thing is clear. If any doubt, please ask me. You need to ask the doubt. Fourth token, fifth token, sixth token, seventh, eighth, and ninth. That's it. So these are the 9 tokens we have. Keep asking the question. If you have any doubt, please keep asking the question. Keep replying. If you are replying answer, if you already know the answer, please help other people. If you will reply, other people also will get benefit from that. Okay. So please keep replying also. And if you have any doubt, please ask the question, because you believe me, other people also have that. Many people also, other people have same doubt, but they are not asking. If you are asking, please, you are helping other people also. Both way you are helping. If you are writing the answer, you are helping. If you are writing the doubt, again you are helping. Okay. So another question, please tell me how many tokens are here. Please tell me how many tokens are here. Try to count. Even you are trying it first time, please make a try. Give a try. Please find out how many tokens are there in this code. Find out, please. We will finish this topic. We will not left anything, and they cannot ask out of the concepts. Actually, we will cover each and everything from this concept, and this is one of the most important one. We have lots of gate questions from this topic. We will cover right now, and you will see that they are asking the question from here. We are covering 5 most important topics in compiler in every subject. Why we are covering 5 only? Why we are not covering 10 or 15 or 20? Because one thing is, we have selected out of 20, we come to 10, then out of 10 we come to 5, and these are those 5 topics from everywhere question is coming on. So maybe they can skip 1 topic, 2 topic, 3 topics, still we have 2 topics out of 5. If 2 questions are coming from these 5 topics, I think you can easily clear the gate exam. If you get benefit after gate exam, please come back and write in the comment section. You get benefited. That will be the fee of this lecture, actually, of these all series actually. So we get answer, that is 12. So let's try to find out. 1 token, 2, 3, 4, 5, 6, 7, 8, 9, 10. All doubts will be clear. Don't worry, all doubts will be clear here. So let's check out if I'm right or wrong. Yes, there are 10 tokens only. So how I'm counting here? Now you may have one doubt. One doubt can be like that. Okay, why I consider plus as 1 token? Plus as 1 token. Okay. Why I do not consider one plus as 1 token, another plus as another token? Okay, why not like that? One question can be this, which I think can be asked here. So you can note down one important line. While finding the tokens, your lexical analyzer will try to find out the longest string. He will try to find out this lexical analyzer will try to find out the longest string which he knows actually. Okay, for example, he know plus, definitely he know plus also, but he know plus also. So to whom he will recognize? He will recognize the longest string. He will recognize the longest string as a token. Okay, that will recognize the longest string as a token, longest string. So plus will be recognized as the 1 token rather than single plus, and rather than 2 tokens, this will recognize as a 1 token. So this is the same thing is written here. One more thing actually written here. Another doubt can be why I consider these have 2 tokens. Here, if you are actually, we know that ABC is a pointer. ABC is a pointer. Okay, but this is how compiler is finding out. Okay, ABC is he is taking the name of the pointer as a different token, and this star as a this star as a different token. So this will be considered as a different token. Again, the same question may be asked, okay, why that is doing like that? This is how the compiler is designed. There are some unique cases which I'm trying to cover with the help of these examples. I will cover all the cases. You will be left with no other cases. I will cover all the cases, which are the exceptions I'm covering. That's why I'm writing here keys. So here, what is written there? Here, ABC and star are considered as different tokens. This is how your compiler is behaving. We are talking in the context of C compiler, which is your BTech syllabus actually. In BTech syllabus, we discussed about the C compiler only, that is given in the Ullman book. So here ABC and star are considered as different tokens, even though they together represent the same data type. They together representing what? They're together representing is their ABC is a pointer. Okay, but compiler consider this as different token, this as different token. We cannot fight with the compiler. This is how the compiler is designed. C compiler is designed. Similar way we done in the previous example also. This is considered as different token. This is considered as different token. This is considered as different token. One thing is sure, we will cover all the different these type of concepts. Okay, we will cover all these keys. All these keys we will cover with the help of these examples. You will be left with nothing. So do not need to worry about that. So we will be able to solve the questions, every question. Okay, because we will cover all the concepts. These exceptions will be covered. So let me check out plus. Okay, you are asking. Harsha is asking if we have plus. If we have this thing, then see, we are starting from left, finding out the longest operator. Which is the longest operator? Plus. This is the longest operator. This will be considered as one token, and then we left with 1 plus. This is considered as second token. Okay, so we have two tokens in this. One is this, one is this. Please ask the question. You are clearing not only your doubt, but many other people doubt. Okay, so we have lots of examples. Don't worry, we have lots of examples also. So before moving on, I think there is another point also here. Yes, there is another key which we already discussed. That's why I write it here. Longest string will be considered as the token. Longest string will be considered as the token. You are moving from left to right, and whichever the longest operator you are finding, that will be considered as a token. Okay, longest string will be considered as a token. Now they are using these concepts only, and they are making the question. They are trying to make the question tough. But if you know this concept, they cannot make fool of you. You just need to do practice little bit, and we will do practice here itself. We have lots of time with us. 1 more hour we have. Okay, again one question. Sainath is asking, but sir, in programming, this never happens. This we will cover the PYQ also. Okay, Sainath, we will cover PYQ. Lots of PYQ we will cover, and you people will solve it yourself. I am just clearing all the key points, which is very important. If we will directly jump over there, then you will actually, what will happen is that you will think that I'm not able to solve the questions. You will make this assumption in your mind. But if all the concepts, all the keys will be known, that will make easy for you people. Okay, because you know already. So the question is, this is not in the language, in any language, then how this can happen? Maybe the person is first time he is programming, he don't know that, okay, this is some operator. He know that this is incrementing by 1, by mistake he write it. Okay, now important point here is that lexical analyzer phase, first phase of compiler, will not find out this syntax error. This is a syntax error. You are right. This is a syntax error. This is not defined in the compiler. Plus. Lexical, this is not the duty of lexical analyzer phase to identify something is wrong with this. He will pass on this thing. He will count the tokens. He will pass on. Okay, then who will find out the syntax problem? Second phase of the compiler, syntax analyzer phase. That will identify that okay, this is not the right syntax. That will generate the error. That will generate the error. Not the lexical analyzer. They can ask the question to you. They can give you wrong something wrong. Okay, they can write the something wrong. They can give you something wrong code, and they give you one option, none of the above, or maybe they give the one option, syntax error. Syntax error is given by the second phase of the compiler, not the first phase. Lexical analyzer don't give the syntax error. That do not give the syntax error. That is given by the second phase of the compiler. So lexical analyzer is not bothered about the syntax. We will cover this thing also. Okay. So let me move to another question. Then I will move to the chat box. So you people please try this question yourself again. Please try this yourself. And meanwhile, let me check out the chat box. Yes, Harshay. Lexical analyzer is not bothered about the syntax. Yes, second phase of the compiler is bothered about the syntax. Please give me the answer of this question. Please try it. Right or wrong doesn't matter right now. Right or wrong doesn't matter in this class. That will matter in the exam. Okay. Here, you are wasting your time with me because you don't know. If you already know why you are here, you must be watching something on Netflix. Why we are wasting time here? Because we don't know. And if you don't know, please ask the question. Okay, and please try this. Please try it. Please write the answer. Whatever you are writing, that is the important thing is you please give the answer. Important is not that you are giving wrong or right answer. Believe me, that is not required right now. Even you will give wrong answer, you are still learning. We are learning here. We are not proving ourselves right now. We will prove in the exam. So all the people are saying 15, 15, 15. Some are saying 8 also. Keep trying, keep trying. Okay, let's try. Let me try also. So this is one. Wrong or right doesn't matter. Doesn't matter at all. Right now that it doesn't matter. In exam that can matter. Second token. See, this will be considered as one token. Everything in the courts, everything in the court will be considered as one token. Already we get, I think, one right answer also, one or two from Anku and Kavya. Let's check out. So this is the third token we get, fourth token, fifth token, sixth one, seventh one, and this is the eighth one. So we have 8 tokens here. So we get one more key. We get one more key. You try it yourself. So you will keep remember now. You try, you write the answer. So you will keep remember that, okay, everything inside the courts will be considered as a one token. This is how compiler is behaving. This is how compiler is designed. So 8 tokens are here. And the key is, what is the key? Key is everything inside the double quotes will be considered as one token. Everything inside the double quotes will be considered as one token. With the help of, again I'm repeating, with the help of these examples, we are covering all the keys point. Okay, so we are covering all the, we will not left even a single one. Okay, and after that you will be able to solve any gate question. So next question, please try it. Please try it. Please write in the chat. Please write in the chat. Everyone, please. We will cover all the key points. You will left with nothing. Take this complete GATE crash course. I'm giving you surety. You will clear the GATE exam at least. If you don't know anything right now. If you already know, please attempt again this. Please attend this GATE series. Your most important topics will be revised. Everything we are covering, each and every point we are covering in every lecture. And we are not relating that lecture from previous lectures. Every lecture is just like individual lecture. Okay, so attend this series and you will get benefit. So it's a gift from Geeks for you people. Geeks is always helping the students. That is always trying to help the students in every way. It's not because I'm working here. It's because I have myself also used GeeksforGeeks. It's not because they are paying to me. It's not like that, but you already know that. Okay, we get same answer. Divyanshu, Sainath, Harshay, Jerry and Kavya, everyone is saying 5. That must be right. That must be right. 1, 2, 3, 4, and you get the point actually. You get the key point. You get the key point here. Everything inside the single quotes also will be considered as the one token. You already know this thing now. You already know. You already check out this thing. So everything inside double quotes is also one token, and everything inside single quotes also is considered as one token. Okay, great, great. Another example. Please find out the tokens. Please find out the tokens. Please write in the chat. Everyone, please. I know you people may be hungry. It's lunchtime, but I am also hungry. Believe me. If we will take the food, believe me, we will all will sleep. I will also sleep. If I will eat the food right now, I will also sleep with you. And we will spend 1 hour in sleeping only. So 12, 12, 12. Many people are saying 12. Keep trying. Everyone, please keep trying. Please write it in the chat box. If you already know, if that's easy for you, still you write. Please help other people. If you don't know, don't worry at all. Nobody know here to us. At least we can share right now here. Okay. Nobody know us on this chat box. Okay. So this is first one. This is second one. So double quotes. This is third one. This is fourth token. This is fifth one. This is sixth one. This is seventh one. This is eighth one. K is ninth one. This comma is 10. This M is 11. This closing bracket is 12. So all the people are giving the right answer. So 12 tokens are here. And what's the key point? Why I give this example? Actually, you already know this key point. Lexical analyzer do not bother about the syntax. You can see here, if you know C language, we have written here 4 variables, but I need to write percentage D 4 times. If I'm printing 4 variables, I need to write percentage D 4 times if you know C language. So this syntax is wrong, but syntax analyzer is not bothered about the syntax. He will count the token, store the variable into a symbol table, and pass it to the second phase of the compiler, syntax analyzer phase. This is the duty of syntax analyzer phase, to check if the syntax is right or wrong. For lexical analyzer, he is not bothered. Lexical analyzer is not bothered about the syntax. He will simply count the tokens and pass it. Let's move on to the next example. Sixth example. Please find out. We are not bothered about the syntax. Please start from here. Please find out number of tokens. You will be able to solve every question. Keep trying. You will be able to solve every gate question. Please keep trying. Please try it and write the answer in chat box. If you like this session, please give some time to give a thumbs up. That will boost my confidence for the next lecture. I will put more energy. I will put more good content in that. Please give a thumbs up also. Okay, we are getting the answers. So we are getting different answer right now. Some people are saying 10, 11, 12. Yes, Secret, thank you. Thank you for... Please like कर दीजिए session को. That will boost my confidence for the next session. I will put more energy. Maybe I will take the keyboard and I will break the keyboard in front of you. I will show more energy I have. Okay, okay. So let's try to find out. Doesn't matter, answer doesn't matter, right or wrong. What matter is right now we are trying, because we are learning when we are trying. Okay, okay. Again, same rules we will apply, keep applying, which we learned till now. Okay, we are finding the longest. We are finding the longest operators. Okay, so after multiply, plus is not an operator. This is not any operator. Okay, multiply and plus. So this is one token. After that, longest operator is plus plus. This is another token. This is another token. This will be another token. See, plus multiply is not any operator in C actually. So plus is another token. Multiply is not any token. Okay, so we need to consider single as a one token. Again, single multiply as another token. See, multiply equal to, this is a token, this is a operator, this is a operator in C, we know. So this is one token. We need to take the longest one. We need to take the longest one. Plus plus another token. Again plus plus another token. And this is one token again. This is AND operator in C. So total we have 11. Let me check if I done it right. Yes, we have 11 tokens here. We have 11 tokens here. The only rule I apply here is that I try to find out the longest one. Every time I try to find out the longest one. Multiply plus was not making any operator. So multiply, I left it. And plus plus, then minus minus, then plus plus, then plus, then multiply, multiply equal to was there. This can be a little tricky. So multiply equal to was there. Plus 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 plus, and this is also AND operator. Okay. And single, this is address of. This is address of operator. Okay. If you want to find out the address of something. Okay, if you want to find out the value, then this is can be single, can be used for value also. Okay, that is different thing. Any doubt in this, please ask. Any doubt. Important is that keep clearing your doubt, because now I think examples are almost finished. After that, gate questions we will cover. So this is the last example, I think. Yes, after that you need to solve the questions. I will sit and you will solve the question. Please try to find out, check out the question, and you need to give true or false. Okay, so you can write like this. For first, is this true or false? Second, true or false, whatever is that you need to write. So what is this question? Okay, let me read. Which of the following string out of these 6 string, which of the following string can definitely set to be a token? Which can be set to be a token, definitely can be set to be a particular type of token without looking at the next input character. Okay, without looking at next input character, without looking at next here, what is the next is coming, what is next is coming, without looking at here. Can I tell which type of token is this? Is this an operator? Is this a function? Is this a keyword? Can I tell this thing without looking at next character here, maybe here, maybe here, maybe here, here, next character, without looking at next character? Which of the strings here I can ensure that, okay, this is a particular, this type of token. So if you can tell, then say true, I can tell, otherwise say false, I cannot tell. Without looking the next character, what is the next character here? After this float, if I'm not able to read what is after this, can I tell what is this float is? Is this is a token or not? Or what type of token is this? Can you surely tell this thing? So I hope you understand the question. If you don't understand, you can ask this thing also. Sir, I don't understand. You can completely ask, sir, I don't understand the question, or you can ask something what you don't understand. 6 is not visible, that is plus plus. 6 is plus plus. Let me write 6th here. Let me write 6th here. 6th option is, let me write, 6 is plus plus. Okay, so let me write here. 6th number is plus plus. Please try it. What is important is you are trying or not. That is important. let at least let at least make sure that we will clear the gate exam. At least clearing the gate exam we will ensure with this series. I'm not giving you the surety for 60 marks from this series, but I can assure you, because we are covering the most important topics only, which are every year is coming, and we are covering everything. We are writing complete over there. Otherwise, no, anyone can claim on us. How you are writing complete if you are not completely covering the topic? GFG cannot do like that. Geeks or Geeks cannot give the false promise. That is a brand. So please try. Write the answer. Everyone, please try. Right or wrong doesn't matter at all. Right now, that doesn't matter. Okay, which one is? I think you're telling about true. Divyanshu, is this true you're talking about? Divyanshu, is this true? True. You are saying that fourth and sixth are true or false? And Kavya, you also writing five. What is five means? Five is true. Okay. So let's check out. And this is the last question. After that, we will cover the gate questions. So we are saying that our lexical analyzer is moving from here, moving on, character by character, that is scanning, character by character. After reaching at here at R, he is not allowed to go further. See, he cannot decide. He cannot decide where is the identifier. He need to scan the next character. After scanning the next character, if he find out there is a space here, there is a space here. If there is a space after where, then this is an identifier. But if there is a bracket here, then this will become a function. Okay, and maybe that can convert it to some keyword also. I don't know, maybe that can make some keyword. At least that can make these two things. So unless I cannot look at here, I cannot make sure. So this is false. I cannot identify here. Same the reason here. After float, this is a keyword, no doubt. Float is a keyword. But without looking at the next character, I cannot say float is a keyword, because maybe there is a bracket here. If there is a bracket, now this is not anymore is a keyword. This become a function. Or maybe after float, I get float 1. I write float 1, 2, 3. So now this become a variable. Float 1, 2, 3. This is not anymore a keyword. So without looking at this particular next character immediate after this, I cannot find out which type of token is this. Okay. And what about this? The same reason apply here also. I can write 1, 2, 3. Now this become a variable. Without looking at next character, I cannot say anything here also. What about this? See, after this semicolon, nothing happens in C. If you see that, we terminate every statement with semicolon only. Okay. So here, even we do not read the next character, even we don't read anything, I can say that this is a token. This is a semicolon token. Let me write one statement. Can you tell me what is the meaning of this? I equal to 5. Now I'm writing C. This is in C. I'm writing J equal to 10. Immediately after semicolon, I write J equal to 10. So is this will give some error in C? No, this will not give error in C. This will completely fine executed. 5 will be stored in the I, and the statement will terminate, and J10 will be stored in the J. Okay, so this semicolon is sufficient in itself. We do not need to look at the next character. This is showing the end of a statement in C language, okay, or C++ or Java. So this is sufficient in token in itself. So without looking at next vector, I can say, okay, this is a token because this is not making any other, this is not using any other symbol and making something else also. Okay, so yes, this is a, I can say that without looking at next vector, I can say this is a token. What about this? Here I cannot say. Why? Because there can be multiply equal to. There may be equal to after this. If there is equal to after this, now this is not more a token. This is a token now. This is a token. I need to look at here. I need to look at here before making a statement. Okay. I need to look at here. And what about this? This is a token. Why this is a token? Because even I have one more plus, still this will remain a token. Whatever you can write after this, whatever you can write, that will not bother this person. And this is a token actually. Yes. So fourth and sixth, I think sixth is not visible. So sixth is also a token because after plus plus, if I'm writing one more plus, still this will remain a token. I do not need to bother about what character is coming after this. So sixth is also right, fourth is also right, all others are false. Any doubt, please ask. Any doubt, please ask. Otherwise, now it's your exam time. It's not my now we have covered everything about the lexical analyzer. You people need to solve the gate questions. So gate questions we will do right now. So let's move to the first gate question. Gate 1988. Please try it yourself. If you people will solve the question yourself, you will get the confidence. If I will solve, believe me, you will not get the confidence. Please try to solve this question now yourself. These are gate questions. These are not designed by me or any of us from Geeks for Geeks. These are gate questions. So this is the level you need to achieve. Actual level. These are the actual questions you need to solve in exam. So I'm going to cover many questions. Please keep trying all these questions yourself. Please try them. Wrong or right, again I'm saying doesn't matter. Wrong or right doesn't matter. Right now that doesn't matter. Please try it. That's why you people are here. That's why you people need to raise your level up to these questions. Please try it. Everyone, please. Everyone, all people, please try it. Please give the answer in the chat box. Now you are solving. I will increase the level of their difficulty also. Don't worry. If you are too much comfortable, don't worry. We have higher level of questions also here. But one thing is sure, you will be able to solve all the questions. These are they can make little bit modifications and all that. Otherwise, they cannot change the concept. So maximum people is giving the C answer, and you people are right actually. That's why we are studying this topic. Definitely, we are going to talk about this thing also. In a compiler, the module which checks every character of the source text. Who checks the every character, not string. I'm talking about character by character that will keep moving on. That is done by the lexical analyzer. Okay, that scan character by character. Who is scanning character by character? There is a machine which is working behind that. That is finite state machine actually. Finite state automata is working behind the lexical analyzer. Second question from 1995. Please keep trying these gate questions. That's why you people are here. You need to raise your bar. Write in the chat box. Everyone, all the people. Please give the answer. Right or wrong doesn't matter. Everyone. So all people, you people, all are right. The answer is C. And actually, this is talking about Pascal language. This is the old question actually, but we are not that much bothered about this Pascal language also. This is the actually keyword in Pascal, but again, if I don't know, I can put something bracket here and I can make it function. So I need to look at next character here also. This can also be a function. So these are wrong. This is a not operator, not operated in Pascal. If you want to write not in Pascal, then we use these angle brackets. This means not, and so this is the right answer. Without looking at next character here, I can say that this is a token. This is a not. Okay. Okay. So let's move to the next question. This is ISRO CS 2020 question. Please try to solve it yourself. You people can solve it. You people can attempt all these questions. Okay. You have covered the topic. That's it. Now you can appear for any exam actually. Please write the answer in chat box. So 26 we are getting from many people. I think if other people are trying, please keep trying it. See, if I'm explaining it and you are still trying, please you keep trying. Okay, that is more important than whatever I'm explaining here. The new information is not that much important as compared to if you are trying it yourself. That is more important. Okay, so you must be right. Actually, your finding is 26. So let me try also. This is 1, 2, this is 3, third token, this is fourth token, this is fifth one, this is sixth one, this is seventh one, eighth, ninth, 10, 11, 12, 13, 14, 15, 16, default is 17, this colon is 18, this B is 19, 20, B is 21, this plus plus is 22, this colon semicolon is 23, break is 24, this is 25, and this is 26. So you people are right, all are right. You are this is not too much old question and you have attempted. That is answer is 26, that is C. You are right. Let's move to the another. This is also ISRO question 2017. Please try it yourself. Little modifications they are making. Okay, but read it carefully and try to solve it. Okay. If you will think yourself, then only you will be able to solve the question in exam. Think yourself. Think over it. Wrong or right doesn't matter. So again, maximum people are giving the right answer actually. That is C. C is the right answer here. So let's check out. If you are trying, please keep trying. Okay, you can put me on mute and you can keep trying. That is more important. In some programming languages, an identifier is permitted. Identifier is permitted to be a letter followed by any number of letters or digits. This is actually happens in almost every language. If you want to declare some variable that start with a letter, and that can followed by any number of letters or key or digits actually. Like I can write A, B, C, and then I can write the digits also like this. First character must be the letter. Okay. After that, I can write any number of letters or digits. Okay. So this is happening with almost every language. So identifier, if L and D denotes the set of letters and digits. Yes, this is representing the letters. L is representing letters and D is representing digits. Okay. Okay. Then which of the expression defines an identifier? Then which of the expression is defining an identifier? Okay. So this question is actually mix up of you can say automata and here to this lexical analyzer also, because lexical analyzer is also finding out the identifiers. Okay, and this will be the DFA for finding identifiers. We need to make the DFA of like that this type of machine we need to make to find out the identifier in lexical analyzer. Why you people are giving the maximum people are giving the this answer is because we are saying that one letter is compulsory. L is compulsory, one letter is compulsory. After that, I don't know how many letters and digits can be there. Even there can be zero also. This star means, this star clausure says that the value can be zero here, or there can be any number of, any combination of letter and digits. But one thing is sure, that you start with one letter. Okay, here we do not mention L. Here we do not mention L. So see, identifiers must have some, first of all, identifier must have some character in that. Okay, so here I can have null also. And other thing, I can start from digit also. So I cannot start with digit. He have given the definition of the identifier that must start with the letter, then must start with the letter. Here this is the this will be like this only, LD. This is binding also to us. Okay, we can have L itself also as a identifier, like only letters we have. Why we need to have digits. Here again, that is binding that, okay, that should be in this sequence, that is starting with L with letter, but after that he is saying that should be like this, LD means like A2, like B3. But if I what about if I want identifier like this, A only? So this cannot be achieved with this and this also, B and C. And this is, in this I can start with digits also, but start should be with the letter. This is happening with every language. In every language we start with a letter. After that there can be any number of letter and character. So C is the right answer here. You people are right. C is the right answer here. Let's move to the next question. Please try it. GATE 2000 question. We need to find the number of tokens in this C statement. Please try it. Please keep trying it. These questions are not designed by me. These are GATE questions. We will take out all the questions. Okay, don't worry. We have lots of GATE questions with us. ISRO or GATE questions. Harshay, Veer, Divyanshu, Kavya, Jerry all give the right answer. Varun also give. So all are giving the same answer. So you people must be right actually. So this is one token. You can say that, sir, in C, printf do not start with capital letter, but lexical analyzer is not bothered about the syntax. He's not bothered about the syntax. 2, this is third token, fourth one, fifth one, sixth one, seventh one, 8, 9, 10. Yes, you people are right. C is the right answer. Let's move to the next question. Any doubt? Anyone? You can ask. 2011 question. Try this. I'm checking that. Okay. From so many questions, from examples also, you can check out in the chat box. We are giving C as the right answer. So don't think that in exam you need to write C every time. Okay. So I have, I think, taken C as the right, option everywhere. That doesn't mean that C will be the right answer. If we don't know the answer, we are going to click C. So C is the right answer. You are right. So keywords, if, for, switch, these are the keywords. Any other keywords are all find out by the lexical analyzer. Lexical analyzer is finding out. These are also tokens. One type of token. They are identifier also. They can put identifier also here. They can put operators also here. All are recognized while the lexical analyzer phase. All the symbols are recognized. Everything is recognized while this phase only. Okay. Divyanshu says Jai Mata Di. C. That's right. Okay. 2011 question. Try this. Please try this. So Sainath is asking about the notes. The notes of all the lectures in this series is available on the page, actually on the Gate Crash Course page. You can find out the link in the description. Actually, there is a link to this complete course, not only this lecture but complete course. Okay, complete course notes are provided. Every lecture notes are provided on that particular page only. That is free only. This course is free for you people. You need to if you want to access the content, all the notes also, then you need to register over there. That's it. This is what you need to do. You need to register over there for this course, so that we can you can authorize yourself. Okay, you are just for authentication. So register yourself and you will find the notes for all the lectures, not only this lecture also. All the lectures notes you will find out there, and all the content, previous lectures also which you have already done. Everything will be in a managed way. And if I can show you here also. Okay, so give me some time. You try this question. So let me show you this here also. So what you need to be done, you can check out in the description, or even you will write in the Google also, Gate Crash Course. GFG, you can write like that, Great Crash Course GFG. So here, so this is the first link you are getting. See, first link itself you are getting. So this is the Gate complete crash course, which is, you can see, that is free of cost, no price, zero pricing. With zero pricing, complete course is there, and we'll find out all the detail. This is the lecture is right now going on, Lexical Analyzer. This lecture is going on right now, 12 to 2. And today itself there will be lecture from 4 p.m. to 6 p.m. of digital logic. Actually, that will be from Biplay, who is from IIT Kharagpur. So he will deliver that lecture today for digital logic. Everything will be, all topics are individual. Okay, we are considering that All you do not need nothing you need. The prerequisite is zero. That's it. Okay. And all the schedule is given here. You can check out. These are the mentors like Joy Jyoti from. He is right now in IIT Madras. You can check out. This is me. I'm pursuing my PhD from DTU. Avinash sir, who is a very senior faculty. Shakshi, who is very good at mathematics, and Biple, who is from Kharagpur, IIT Kharagpur. So these people are going to help you. You need to just register here, and you will get the complete notes here only. Complete notes after registering. Okay. Okay. So let's move. Let me close this and let's move back to our to the next question. I think yes, this is the. So you already given the A answer. A is the right answer. So, a lexical analysis of a modern computer language such as Java needs the power of which of the following machine model in a necessary and sufficient sense. Okay, this is needed for lexical analysis phase. This machine is working behind that. Okay, finite state automata. This machine is working. 2018 question. Try it yourself. Little bit hard one, but please try it. Please, everyone, try it. Try it. Okay. So let me get aside so that you can see the complete screen. आप लोग भी बोल सकते हो मेरे को सर प्लीज साइड हो जाओ यू आर डिस्टर्बिंग अस यू कैन आस्क मी एनीथिंग okay Varun says that last option is not visible. Last option, let me write here. D option is T3 and T2. I hope that is the answer. T3 and T2. Harsha says that she is also not available, visible. So C is T2, T1, T3. I can see that many people are able to solve this question also. So this is a good question, actually good question. I will say that uh, from gate point of view, this is a good level of this a good level actually. So if you people are able to solve this question yourself, what I will suggest to you people is that you please take some test series and now you have to go through the test series also because you need to now practice lots and lots of question. It's better you take one or two test series even I will say, not only single one. Take two test series which you find that okay that can help you, and please attempt to solve the question from there. Okay, if we are able to score good in the test series, like if you are able to score good in the Geeks test series, that will ensure you that okay you will get below 300 rank. That will make this thing show to you if you are able to score good in that, because there are good level of questions are there, and if you are able to solve this question, then definitely you have to go for the test series because you have great chance to get rank below 300. Wrong or right doesn't matter. You people please try it. This may take little time. It's okay. So let me wait for one last minute. After that, I will also try. Otherwise, you can keep trying. That is more important. After 1 minute, I will try this. Okay, I think I have to try now. If you people are trying, please keep trying. That is more important rather than even listening to me, because you can find out this explanation later on also in the recorded part. So if you are trying, that is more important. Okay, so a lexical analyzer use the following pattern to recognize the tokens T1, T2, T3. So we have three type of tokens from these alphabets ABC. And here important part is here is that they are telling us the meaning of this a question mark. Okay, what is the meaning of this? Let's suppose X question mark is, this means either I will consider X or I will not. Either I will consider A or not. Yes or no, 0 or 1. Either I will consider the occurrence of A, this is telling me, either I will not consider. Similar for B, similar for C question mark. So this statement is telling this thing. Note that X question mark means 0 or 1 occurrence of symbol X. Either X will occur or not occur. Okay. So note also that analyzer output the token that match the longest possible prefix. We already know this thing otherwise. Lexical analyzer always find out the longest one as a token, that recognize the longest string as a token which he can match. So we design a compiler, let's suppose, and we say that these are the three tokens in my compiler can recognize these three tokens. Okay, I designed these machines, uh, finite state machines for three tokens, and then I give this string I give, and we need to find out, okay, we need to find out which of the tokens are there in this string, which of the tokens are there in this string. So let me write the string a little bit in big font over here, B B A A C A and BC. Okay, so we need to find out the longest possible prefix. From this side, left side, I'm moving to the right side, and I'm finding the longest one which can match over here. So first I get B. So B I can get from here, yes. From here also, how I will get B from here? I can make this as 0. I can say that, okay, I'm not considering A. So I can consider B from here. Okay, I can consider B, any number of B or C from here. So I can consider B. From here also I can consider B. From here also actually I can consider B. I can consider this as null, nothing. And from here I can consider B. Okay, after that, but I'm looking for the longest one. Okay, so which of these token is finding is able to match the longest prefix, match the longest substring. Okay, so let's see how many maximum character this can match in one go. So one B that can be matched. Second B also I can generate from here because star is here. B or C star. So star closure is here, so 2 times B I can generate. After that A also I can generate from here, this A, but the second A I cannot generate. So maximum substring which I can generate initially from this token is BBA. Okay, and let's check out from here. From here I can generate B, yes, first B. Second B, no, I cannot. Yes, second B I can generate, but from here I can set this to null because star is here. So 1B, second B, only 2B I can generate. Okay, so this is the longest substring I can generate from this token, and from this token I can set this to 0, and from here I can generate 2Bs, first B and second B, yes. After that A, even I can generate 2A, yes, up to here now. After that C, yes, I can generate C also after that. So from here, this token, from this machine actually I can generate this longest possible string. So according to this statement, we need to consider the longest one, the tokens which is considering the longest possible prefix. Okay, so this can detect only this much, this can detect only BB, and T3 can detect up to this long. T3 can detect 5 character long prefix. So I need to consider the longest one. So first token I will find out, I can say here is this. First token I find out is this. This token is actually T3. This token is T3. Okay, now I need to find out this thing. Can I generate this thing from here? Let's see. A I can find out here. B I can find out. C, no, not C, but A and B I can find out in this ABC. Here A, yes, B, yes, C, no. After finding A and B, I cannot get C. So A and B here also. Yes, I cannot find out C. And what about this? A, yes, B, yes from here, C, yes from here. Okay, so I can find A, B, C from here, T3. Okay, so longest string can be found out by T3. Longest string can be found out by T3. Okay, so from T2 and T1, from T2 and T1 I can find out only 2 characters, but longest one is found out by this one, so I will consider this one. So in this string, I can say that according to these statements, these are the tokens I will find out. These are the longest, these are the tokens which is helping us to find out the longest prefix. Okay, so this is the answer. So D should be the answer. Actually 3 must be here. If we, I don't know why you are giving the D as an answer. If I write T2 here, I cannot write T2 here. T3 must be the answer. T3 must be the answer. So D is the right answer here. D is the right answer, but the option should be T3, and the option is T3 only. I was not able to read here, so option is T3, and this is the tokens we find out. If any doubt, please ask. And Veer, what is your answer? You are wondering why your answer is not matching, but where is your answer? Let me check. Okay, you D is the right answer, but this should be T3. But T3 and T2 you cannot say. Why? If you are considering T2, okay, you are considering, okay, this as a token now. This will be T2 token. This is T3 token, this one. Now for this also you need to consider a token. For this you can take actually this token, again T3. But according to this statement, we need to consider longest possible. We need to consider that token which consider longest one. And longest one is considered by the this T3. Longest one is considered by the T3. You can take another example also. If I write like A, B, C, A, B, C, A, I can make any question out of here. So here I can say, okay, which are the long, same question with this is the input string. Now, which are the tokens? Can you tell me which are the tokens? Please try again. Okay, please try again. Which are the tokens? You will say that, okay, that should be the right token. Can you people tell me which for this string? Please try. Please try. Harshit say that if you people try this, otherwise I'm taking some question from chat box. If T3, Harshit says that if T3 and T2 are the options, then what is the possible option which can be answered, sir? Okay. So in that case, we need to find out. See, possible answer in that case will be T3, T2. If let's suppose this is T2 only, then we need to consider T3 again. The answer should be T3, T2, and T3. This must be the answer. And T3, T2, T3 is not given here. So no option is satisfying the answer. No option is satisfying. If I can say no option is satisfying the answer. Okay. If T3 is not given, then I can say only one thing. No option is satisfying here the answer. Otherwise, they need to give one more option, none of the above. Otherwise, the option is wrong. And this also happens sometimes in GATE exam. None of the options is actually is right, and they give marks. Whoever attempt the question, whoever write any of the option, everyone get the marks for that question. This also happens in exam sometimes, like, but for this you are trying. So we already get the answer T3, T3, T1 from Divyanshu. I think Divyanshu is right. Yes, Divyanshu, you are right. So this is the longest string I can generate, which is can be generated from T3 itself. You can check out here. Again, T3. This can be generated triple A directly from here because this is ending with A. No other token is actually ending with A. We need to consider this only, but wait, we have triple A, so we can generate 2A from here, but we need to take even this is T3, this is T3, this is, I think this is T1, again this is T1. So this will be the answer. You cannot generate 3 A's from here. Can you generate 3 A's? No, we cannot generate 3A from here. We can and no other we can use actually, because all are having ending with B and C. We need to use T1 only, but in T1 you cannot generate 3 A's. We can generate at a time 2 A's only, because A is not having star closure anywhere. I can consider 1A and 2A, and last A is also generated by T1. So the answer should be T3, T3, T1, T1. Yes, Veer, you are right. And sir, should not it be 3 times T1? No, not 3 times. We can generate 2 A's actually from T1. 1A we can consider this, 1A we can consider this. Okay, that's it for this question. Now we have spent so much time over here. Please try this one. It's for 2017 one. Let's try to cover maximum questions. Please give answer fast now. Everyone, please give the answer fast. So what is the output of lexical analyzer? What is the output of lexical analyzer? We already discussed this thing, and you are giving right answer already. A stream of token stream, a stream of token stream. That is the output of lexical analyzer, which is the first phase of the compiler. We are not talking about the compiler output. We are talking about the one phase of the compiler output. Okay, so D is the right answer. Check out this one. ISRO 2011 one. So let me check out if there is other question also. So this one is also easy one. Which of the data structure? I will come back to previous question. So let's cover the easy one. Which data structure in a compiler is used for managing the information, variable and attributes? Which data structure is used in the compiler to manage the variables, identifiers? You people know. You people already know. So we get the answer also from you. You are giving the right answer. Symbol table. Yes. That's it actually. One more question was left, this one. You can take snapshot of this question and you can write the answer in the comment section. Please write the answer for this question in the comment section, not in the chat box, so that I can also get benefited. Okay. Okay, that's it for this session. And we have covered each and everything about lexical analyzer through maybe by using the concept, by discussing the concept, or maybe by discussing various examples, or maybe by discussing the gate questions also. Okay, but we have covered each and everything. Now you do not need to know, you do not need to go anywhere else for lexical analyzer. It's better now you just take the questions. You can try to find out the question from lexical analyzer. This lecture was sufficient for answering every question actually. Now they will make little bit tricks everywhere, and I hope you will be able to solve each and every question now from lexical analyzer. So thank you everyone for keep joining me for such a long time. For 2 hours you are continuously with me. You do not go for lunch also. So now we can eat the lunch and we can sleep. Anything else to ask? So this is the gate test series from Geeks for Geeks site. So much uh, subjective tests are there, 10 full mock tests are there. So many things are there, and that is also pocket friendly. So you can go for this test series also, which will raise your level actually. And if you are able to score good in this, believe me, you are going to get below 300 rank in gate also. Otherwise, what we can do is at least we can go for this free course, complete this free course. Best of luck, everyone. Keep working hard. Thank you. Thank you, Harshay, for this comment. Thank you, Harsh. Thank you, everyone. Thank you. Thank you, Jerry. Thank you, Veer. Thank you, everyone. So I'm now ending the session. Thanks. We will meet in the next lecture, okay? Okay.